This lesson is titled Advanced Algebra 6-8 on imaginary numbers. Imaginary numbers are numbers that we use whenever there is a negative number underneath a square root or underneath a radical sign. Normally you can't take the square root of a negative number, so we replace the negative with the letter I so that we can continue simplifying the problem without worrying about the fact that it was negative. As you're solving problems, keep in mind that when you do I squared, the result is going to be -1. Let me illustrate how i's are used with the first example problem here. Solve x squared plus 36 equals 0. If you're trying to solve that for x, you would subtract 36 from both sides, which gives you x squared equals -36. If you continue to solve, you would want to eliminate the square by doing the square root. You can see that on the left side, the square root and the square will cancel each other out. On the right side, if you try to do the square root of -36, you'll get an error message on your calculator. So what we're going to do is rewrite that number as -1 times 36. Using the rules of square roots, we can separate that square root into the square root of -1 times the square root of 36. The square root of -1 turns into I, and the square root of 36 turns into positive and -6. When you're all done simplifying those, you're going to get x equals positive and -6i. You treat the I like a variable, so you just put it after the number. So normally we would not be able to solve that problem. We'd have to stop at this point here and say that there's no solution. But if we can separate out the negative and call it an I instead, then we can continue to solve the problem and get an answer. Once you've incorporated i's in your problem, there's different methods you can use for multiplying, adding and subtracting, as well as adding and dividing. So we're going to try some different operations using the letter I. For this first simplifying problem, it's a multiplication problem, and you're going to treat the I at first just like a variable. So we'll multiply 7i times -10i. You'd multiply the coefficients together, so that would give you -70. And then you'd multiply I times itself, which would be I squared. Remembering from up above that I squared is equal to -1, we get -70 times -1, which is simply 70. So we're able to simplify a problem that has imaginary numbers in it into a problem that has a real number answer. You can do the same thing or a similar thing on number 2. Normally we would not be able to simplify this problem because there's negatives underneath the square root. But if we pull the negative out and call that an I, so we're going to separate it into square root of 1 and square root of 25. Do the same thing on the 100. Do the square root of -1 and then times the square root of 100. The square root of -1 becomes an I. So we get -I square root of 25 and I square root of 100. If we know the square root by heart, we can go ahead and do that as well. So we're going to get a 5 for the square root of 25 and a 10 for the square root of 100. Again, we treat the I like a variable, so we typically put the number in front and the variable after the number. So here you would say -5i and -10i. If you treat that like -5x minus 10x, we would get -15i or -15x. So you're able to simplify a problem that normally would not be able to simplify with using an I as your negative square root. Let's try 2 more problems. The one on the left involves adding with imaginary numbers. So again, if you see a negative under a radical, you should separate it into -1 and then the number as a separate radical. Do the same thing again on the second product. So now when we get the square root of -1, that turns into I. There is nothing here to simplify with the square root of the square root of 3, so we just leave it that way. And then we simplify on the right as well. We get an I and then the square root of 3. Here we're just going to take a little mini break and try to imagine this problem as 3i plus 3i. you would add the coefficients together because they are like terms. We can treat this problem exactly the same way. Because the square roots are the same, we can consider them like terms. We can also consider them like terms because the i's are both there. So it's like we're adding an I to another I. So we would add that together to make 2I, and then the square root of 3 is just sitting there. The last problem that we're going to do involves division. So let's simplify the top as square root of -1 and square root of 25. And let's do the same on the bottom. Square root of -1 separated out from the square root of 64. The square root of -1 becomes I on both the top and the bottom. The square root of 25 is positive and -5. And on the bottom, the square root of 64 is positive and -8. If you look at what we have, the i's will cancel. So we just get simply positive and -5/8.